hello, welcome back in YouTube. So looks like the thing's working. Right, hello, welcome back. So today we're going to talk a little bit more about other turbulence models in this OpenFOAM Intermediate series. So yeah, just a few things. Before I continue, I want to just set my delta t, back to, my right interval. I want to set it back to 10. Right. All right. And this is what I want. And I would like to copy this control dictionary. Copy this whole control dictionary. All right. And I want to put it in the SpalartAllmarasIDDES case as well. So PimpoFoam ran SpalartAllmarasIDDES system control dict. So when I change and I see the VI system control dict, everything is over here as it should be. I've actually also run the auto patch on this. I just want to there were some other things I needed to change here as well, such as the new t. I need to change it to a new t wall function. Alright, as I was saying in the last video, I have not done it for this case, but now I have. So just make sure when you have a wall for the new t, it should be wall function. It's not a calculated value. Alright, so let's we can do a PimpoFoam, and we just do an AND or something. So it should run, and it should run much faster than let's say the kOmegaSSTIDDES type calculation. Right, so while it's running, we just want to see what the function object tells us the wall shear stress is, just for comparison between these two cases. Of course, oh dear, hold on, I need to kill that process. Kill 17672. All right. I forgot to change the FV solution, so let me do that as well. Okay, cd PimpoFoam runs, or maybe I'll do it here, cd system, and copy PimpoFoam runs kOmegaSSTIDDES system FV solution, and I'll put here. That should change the FV solution to go from a multiple outer corrector case. Okay, because we had a multiple outer corrector over here, and outer correctors was about 1000, and I don't want that. Okay, so when I copy this over, I actually set the and outer correctors to 1 so that it will run faster, and that's exactly what I was trying to do. So let's do a PimpoFoam again, and let's go. Alright, anyways, next thing I want to do is maybe look at a different turbulence model while this simulation runs. kOmegaSSTIDDES. Alright, what is that simulation? What's the model I want to look at? I want to look at, I'll start looking at large eddy simulation models. Okay. Specifically, this DES models, detached eddy simulations. So let's see, physical modeling, there should be DES over here. Alright, so this is the page I want to share with you. There are several kinds of detached eddy simulations. All of these are actually hybrids between Reynolds average Navier-Stokes and LES. LES is called large eddy simulation. The idea is that, well, I'll just quickly give a brief overview. I'm not going to do too much. Please look at my turbulence modeling if you want to know what these are. Okay, so this, let's say you have a pipe and you're trying to simulate the turbulence. Right? There are two very different philosophies. Okay, RANS. This is called Reynolds average Navier-Stokes. They give a time average of turbulence, and they will use viscosity. It's a turbulent viscosity on nu t to model turbulence, right? you won't actually see the velocity fluctuations when you won't see the velocity fluctuations for RANs when you do this sort of turbulence modeling. So normally in turbulence you expect the velocity to fluctuate a lot. In RANs, all these fluctuations are modeled, they are captured as this turbulence viscosity. Alright, for LES it's a bit different. The way they model it is they try to put 20% of the turbulence in terms of the energy as nu t, and 80% you try to resolve it. What do I mean by resolve? That means all the turbulent fluctuations, not all of them, 80% of them, the larger the larger turbulence patterns, the eddies and all, these will be simulated. You should be able, if you set up your simulation correctly, if you set it up correctly, you should be able to get those eddies visible to you when you see ParaView. Okay, and what is detached eddy simulation? Detached eddy simulation is a hybrid between both of these. Okay, it's a hybrid between the RANs and the LES regions, and the idea is that if you have a wall here, closer to the wall, you want to use a RANs type simulation. You want to use a Reynolds average Navier-Stokes type simulation near the wall, and you try to have it more like a LES simulation further away from the wall, because that's where it is most accurate. Okay, Reynolds average Navier-Stokes actually performs better for forced flows, where you have a pressure driven flow or something, or velocity driven flow or some free stream, that kind of thing. It works well closer to the wall, especially when you have fully developed flow. Now of course, in the middle you have sort of a blending region, between the RANs and the LES, the Reynolds average Navier-Stokes and the large eddy simulation. And why is it called large eddy simulation? If you think about turbulence in general, there are big fluctuations and there are small fluctuations. All right, the small fluctuations are the ones that make it so difficult to simulate all the turbulence. And 80% of the energy, by and large, you can capture it in the large simulations, the large eddies. So these large eddies are very much cheaper in terms of computation time and power. They are cheaper to calculate out and cheaper to show them in ParaView. Okay, all these small eddies, they are much more computationally expensive. Okay, so that's the overview of large eddy simulation, Reynolds average Navier-Stokes, and detached eddy simulation. So detached eddy simulation use Reynolds Navier RANs type near the wall, and they use LES further away from the wall. Yeah, so they use LES further away from the wall. So yeah, how then do you put all of these into our case here? All right, how do you put all this into our case? So I'm going to copy over this PimpoFoam RANs kOmegaSST, okay, into a PimpoFoam template LES. So this is for LES type simulations. And how do you know it's LES? I just said that DES, detached eddy simulations, all this class was a hybrid of LES and Reynolds average Navier-Stokes. But if you take a look at the PimpoFoam list turbulence models, you'll see that all the detached eddy simulations, they are put under the large eddy simulation class under turbulence models. Okay, so there are lots of LES type simulations. They're the SpalartAllmarasIDDES types, and the reason why I was using SpalartAllmarasIDDES before is because most of the entries you need to most if not all of the entries you need to enter for solving of the SpalartAllmarasIDDES RANs models, the Reynolds average Navier-Stokes models over here, this one particularly, they are able to, I mean, the same entries are required for these DES simulations. Also for kOmegaSST, the same goes. So kOmegaSST, as long as you have the entries for there, most of it is easily transferable over to kOmegaSST, the DES, alright, detach eddy simulations. And what is the difference between DES, DDES, and IDDES? You need to take a look at my turbulence modeling video series. You will be able to see what the differences are. I elaborate a lot on that. Well, if you are in doubt, just use the IDDES model. This is the latest model. So actually DES is, the first iteration of the hybrid. DDES is, they found out there's some problems, they kind of improve. IDDES, again you improve on that to expand the functionality. So just use IDDES if you are really in doubt and you're not sure what to do. Alright, so let's go to PimpleFoam template, LES, and let's begin. Now changing it to this LES simulation is pretty easy. So you go to constant, go to turbulence properties, change the simulation type from Reynolds average Navier-Stokes RAS to LES, and save. And the RAS model, just put kOmegaSSTIDDES. Okay, as per what it is, the same as what you were seeing in this place here, kOmegaSSTIDDES. So if all is okay, that is actually all you need to do. Other than, if you study large eddy simulations, you will know that your mesh has to be refined and you got to make changes and everything. But in terms of syntax, this is probably all you need to do to get it to run. So let's do auto patch mesh gen, and yeah, I'll do that first. So let it run. Yeah, but basically that's all you need to do. Now, the thing about this, let me bring up another terminal, Control Alternate T. The thing about this is that you won't be able to find very much. Oh, CD foam tutorial. Okay, alright. So you won't be able to find anything on kOmegaSSTIDDES. So let's take a look. kOmegaSSTIDDES in here, you will not be able to find anything. Excuse me, sorry. Anyway, you take a look. You have kOmegaSSTIDDES. Yeah. So there'll be nothing there. The only thing you will find is the SpalartAllmarasIDDES. SpalartAllmarasIDDES. Oh, there's no SST there. SpalartAllmarasIDDES. So you will see it inside this thing called the periodic hill over here, and also the surface mounted cube. You will not see kOmegaSSTIDDES. But frankly speaking, as long as you have your mesh set up right and the entries right, it's pretty trivial to get it to be the same, get the solvers to, get the solver working. Alright, so remember, we have this turbulence model going on, kOmegaSSTIDDES, and then I'll just run PimpleFoam. Alright, and it will sort of start running, but it will not really run. Okay, so it says LES not found in the turbulence properties. So constant turbulence properties. Yeah, okay, so yes. So what, I actually forgot to change another entry. Simulation type is LES, so you kind of need to change this property here to LES. Okay, it's not RAS. So okay, let me do this. Okay, let's copy this. So I use the visual version. I press V to do that. Yank and paste. Yank is Y, paste is P. Alright, so the RAS model, I'll just leave it here since it's pretty cheap, in terms of data storage, to be able to do that. Okay, LES should be here. So that's what you need to do. Okay, let's try running it again. InfoFoam. Oh, okay. LES model not found. So again, I think I messed up again. Turbulence properties. Yeah, because it says here RAS model. It's supposed to be LES model. Alright, let's do LES model then. Okay, let's try again. Hopefully there are no errors. Okay. There's a entry that they are asking. They say they want this thing called delta. Okay, what is delta? Delta is a length scale. Okay, delta is a length scale, which you should find over here. The length scale, you should be able to find it here. Okay, so delta is a length scale, and how should delta look? So that's where you start looking at the foam tutorials. Even if it's a SpalartAllmarasIDDES, it should still work. So let's go to this LES periodic hill. Okay, and let's paste, and let's go here. CD foam tutorials. Let's go here. Yes. Yep. You'll go to the turbulence properties to see what the file actually looks like. Okay. And it will look. You'll say here it's a IDDES delta. Okay. And this actually needs to be put in. So let's go to constant turbulence properties. Just basically copy this whole entry here and paste. Okay. And paste it here. And so the delta is IDDES delta. This is actually a characteristic length scale, and the coefficients are as such. You'll use the maximum of the delta XYZ cube root. Alright, but I'm not going to explain what these are. You can go and look in the turbulence modeling video series. You should be able to see what these are talking about. Okay, or at least you should be able to get an understanding. I don't tackle every single bit of how to use IDDES and what these are exactly, but watching that series will help you get all the tools you need to understand what you see here. So do take a look if you have the time. Alright, so let's try running it again. So you see, now all you need to do is just to make sure the entries in the turbulence properties are given correctly, and you should be able to run. So the same thing actually works for okay, I'll stop this here. The same thing actually works. It works perfectly well for the SpalartAllmaras version as well. So let me just do something simple. Okay, let me do a clean template LES. Okay, and what I want to do is sort of to copy. I want to copy the rents. Okay, I'll copy this first. InfoFOAM template LES, and I'll put it in InfoFOAM LES kOmegaSSTIDDES. Okay, so that should make it work. Now there's this bit. Alright, it's kind of still running. I'll let it continue, but let me copy over the SpalartAllmaras bit, and we can do the same. InfoFOAM LES SpalartAllmarasIDDES. Alright, so let's go to the IDDES case. Okay, time is up. It should not be taking too long. Let me do an all clean here and do a auto patch mesh generation. I'll just run it in the background. Then what I want to do is go to constant and basically do the same things. Alright, now again a few things you need to do, but let me paste this here first. Paste this entry here so I can use it later. So again, I will use the visual mode. I'll yank all of these and paste. Alright, and I'll change the simulation type to LES. Okay, then alright, so the output is coming for auto patch. So it's yeah, it is done. Let's go to constant. Turbulence properties, so that's why you saw the print out kind of interrupt the VI, but that's part of using a command line, so can get used to that. So I'll change the LES to here. Then we have LES model, SpalartAllmarasIDDES. Sure. Then I will actually want to paste. Let me see whether I can still paste this. Okay. Yeah, it's still pasteable. Alright, and let me delete all of these. Alright, so you have an LES entry. So if all goes well, just running PimpoFoam by itself should be okay. Alright, ill-defined blah 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 in constant simulation type. So let's see, primitive entry. Okay, let's see whether I did any typos. Probably it's some typo thing. All right, I deleted the semicolon. That explains why. Okay, let's try again. PimpoFoam. Alright, so you see it works perfectly. Okay, there's nothing too much to do over here. There's very little work. So once you've done a Reynolds average Navier-Stokes stuff, I mean the SpalartAllmaras or the kOmegaSSTIDDES, switching over in terms of syntax is pretty straightforward. Of course, you got to make sure all the mesh is right. The mesh sizing is right. And for that, do go and look again at the Turbulence Modeling video series. I have a lot of videos detailing how to size your mesh properly. And these are good guidelines. But alright, that is it. Learning how to step into the large Eddy simulation in terms of syntax, that's all you need to do. There's nothing too scary about that. Okay, so that's all I have. I'll be uploading this once I clean this up to GitHub. Yeah, so that's all I have for you this video. I'll see you guys next time. Thanks for watching.